Good morning, everybody. Welcome to the Pacific Wash webinars.
Good morning.
Good morning,
Hello,
Bronwyn.
Elsiva.
Hi, Elisiva. Hi.
Hello. Morning.
Good morning. Hi, Christina. I can see
Hi,
you there.
Christina.
Rosie, Lee Chang, some new names as well. Welcome, everybody. Glad you could join us today. All right, well, we might get started. Thanks so much for joining us today for the last of our Pacific Wash webinars for 2022. This is a webinar series that the Asian Development Bank holds in partnership with the Pacific Water and Wastewater Association on topics of interest for water and sanitation across the Pacific. So we're very pleased today that, is my slides moving? Oh, here we go. Oh, I'll start with some housekeeping. So this is just to make sure that this webinar runs smoothly. If you don't mind, please keep your mic off during the presentation so that we can hear everybody clearly. Also, raise your hand if you do have a question throughout and you'd like to speak. You're also welcome to use the chat box to raise any questions at any time, and we'll come back to those as the presentation continues, and we will have breaks. We'll probably have time for a clarifying question after each presenter today, and then we'll have a section at the end for a Q&A session as well. And I'm from the topic, I think there'll be plenty of interesting conversation today. So the flow of our session will be a first welcome by Lucia Sefaliao, the CEO of the Pacific Water and Wastewater Association, and then we're lucky to have 3 presentations today, first by Mark Ellery, by Sharon Lesser and Raghav Neti, and I'll introduce them in more detail in a minute, and then we'll have Q&A session and close with a group photo. But first, over to you, Lucia, for some welcome remarks.
Okay. Thank you, Bronwyn. Well, good morning and good afternoon to all of you. Firstly, let me say we are very grateful and fortunate for this collaboration with ADB in bringing together all our member utilities to learn from industry and sector experts and from each other through sharing knowledge and expertise in the field and how others are coping with WASH issues. And I hope that, all of you who had been to the conference earlier in the month found it valuable and worthwhile, and that you picked up on the networking with each other over there. It was great to have seen most of you face to face after a long COVID break. So a warm welcome to all of you here. It's good to see some of you here again to discuss today's topic of on-site sanitary behaviors in the Pacific. And I think this is an excellent follow-up topic for discussion after the conference, which focused on water security and resilience. If you had been involved in the conference, you will have heard the ministerial brought up the topic of wastewater and WASH often. SDG 6 is not just about water, it is also about sanitation. And you probably would have heard the alarming rates of access to safe, my emphasis on safe sanitation of the Pacific as a whole in the reports prepared for the ministerial. But in particular, today's discussion is probably even more important because we will be discussing a topic that is considered no person's land, because fundamentally on-site systems are not considered to be a public matter in most countries, and neither is it a private one. I mean, we have septic tanks, for example, and then we forget about them, and we really don't care about it as private residents. So I'm particularly glad that we are having this discussion, but let me not hinder anymore from letting you hear about the presentations that will be made by ADB and also some practical input from Samoa Water Authority by Sharon and the World Bank on their recently approved sanitation project in the Kiribati. Thank you very much for your time, and I look forward to the presentations and discussions today. Thank you, Bronwyn.
Many thanks, Lucia. That was excellent scene setting, and also reminder of some of the key messages that came from the excellent conference that some of us are lucky to attend in Fiji, recently hosted by PWWA and partners. Without further ado, I want to give a bit more introduction. Lucia already mentioned the case studies that we'll have today. So we'll start with Mark Ellery, who's a water sanitation local governance specialist who's worked across many regions and recently done a lot of work across the Pacific. And he will talk to some of the technologies and issues to do with anaerobic and aerobic digestion processes and on-site sanitation options. Sharon will present on the pressurized sewer system in Samoa. Raghava will present, Raghava Neti from the World Bank is a senior water supply and sanitation specialist and will present on a case study from Kiribati, both sewered and on-site systems. And I'll provide a bit of an introduction now. So on to that, just a bit of a stock take on where we are with sanitation access in the Pacific. And as Lucia mentioned, some surprising figures that people prefer still not to talk about sanitation, but it really is a topic that needs discussion. So whilst over the last 20 years, 1.2 million people have gained access to basic sanitation in the Pacific, this has not kept up with population growth, as you can see by the chart on the left. And also you can see from the charts on the right, these are JMP figures, that there are great inequities between rural and urban populations. Today, our focus of our presentations will be on urban populations, but we do know that in the Pacific that those urban populations are growing rapidly, and that many urban populations also now include informal settlement areas. So those populations many of those settlement populations are very challenging to service for utilities. In terms of how urban sanitation is looking across the Pacific, we see that there are 3 countries where there is very low access to basic sanitation, only with 49 to 60%. And then we can see improvements as we move across the Pacific. And I should acknowledge Mark Ellery and thank him for this slide, which is, as a graphical representation of access, very useful. So you can see that there are certain countries that are further behind than others as far as access to basic urban sanitation. This is represented here again in this graph, which shows access to safely managed sanitation, basic sanitation, limited and unimproved, as well as open defecation. Again, just to note that this is urban figures, and in some countries we don't have urban figures, we just have national figures, and that is indicated by the N next to the name of the country. Worth noting as well is that SDG 6 has since been adopted, set a higher target than we had previously of not just achieving basic sanitation access for people, but for achieving safely managed sanitation. And so far we have only 5 countries in the Pacific that are measuring whether or not the basic access that exists is safely managed as well or not. So we can see that where, say, for example, Tonga and Samoa, although basic access is high, that the safe management of that basic sanitation is still fairly low, under 40% for both. So I'm sure some of you are very, very familiar with sanitation, maybe others less so, and I think it's always worth recapping on what we mean by the sanitation service ladder, which is the JMP definitions by which countries' access is measured. We know that basic service is use of improved facilities that are not shared with other households, but safely managed means that waste that is collected is is stored safely and is transported or treated safely, either on-site or off-site. So there's different ways that can happen. So for safely managed, excreta transport and treatment off-site can be done through septic tank. A sewer system can take wastewater and treat it off-site, and a wet or dry pit or other treats excreta and also disposes of effluent on-site, in situ, so on the same plot. I've color-coded those septic, sewer and wet dry pit, and they match this graph, the color codes. So we can see what the breakdown of that basic access is on the previous slide. So you can see here, again, Tonga, Samoa have very high access with septic tanks, and whereas other countries, Nauru, rely more heavily on pit latrines, whereas Guam and Palau, Tuvalu rely more on sewage system in urban areas. Again, just identifying where the effluent sludge are treated, depending on the different technology type. And Mark will go into this in a lot more detail. So what are we talking about when we talk about on-site sanitary behaviours, which is the topic of our session today? Well, we're talking about how householders, people of all ages, genders, in all different places in urban areas, manage their toilet. So we know that that means they're responsible. So there's often a delineation of responsibilities between what happens on-site and what happens off-site. And this is where interaction between utilities and householders occur. So here you can see a pit latrine where the effluent and sludge is disposed on-site, a septic system with a holding tank and a soakaway where the effluent is disposed on-site, and the fecal waste is transported and disposed off-site, or the sludge. And then also in terms of sewage, the on-site behaviour relates to the toilet, and then everything is flushed and then treated with, so the effluent and the sludge is disposed off-site. And we'll hear an example of Samoa of that system. So some of the considerations for on-site sanitary behaviours, the sanitation choice. So we saw in many countries there's already high levels of basic access. So people have made a choice, and urban planners have helped make that choice for them around what kind of technology option they are using. In other countries, there are big gaps in access still. So some important discussions need to be had about what kind of systems, whether they're on-site or sewage systems, should be adopted to service those areas. And that very much relates to what kind of emptying and transport services there are available, and what supply chains are there, and the affordability of those different systems. Health is a very important consideration, and the foundational reason, and Mark will go into the links between sanitation, acute and chronic health issues and stunting. Cleanliness, hygiene matters a lot when it comes to on-site sanitation behaviours, how people use their toilets. Safety and accessibility for all ages and genders matters, and in the Pacific particularly, the location and accessibility of those toilets has a lot of cultural implications, which we need to consider when building and designing toilets. In terms of service sustainability, some of the issues we'll hear about today that matter, particularly for utilities, are around preventing blockages, ensuring ongoing functionality, and minimising the risk of overflow to surface. So this is where we see a big health risk and risk of contamination. And I guess, the fecal oral connection, where we see health impacts appearing. Then also for utilities, costs and options for safe disposal are critical. So in our webinar today, we'll consider what the principles of wastewater treatment are for a good enough sanitation option, where household and utilities responsibilities start and end. And I think it would be interesting to discuss that in our Q&A session. And then approaches to influence household behaviours. So that's it from me on intro, but we are actually hoping to take this opportunity to get some information from you, because we're in the process of planning a training session for the upcoming Water and Wash Futures Conference, which is being held in Brisbane in February 2023. And hopefully some of you are planning to attend. But we are quite keen to understand what is the understanding or terminology that's being used across the Pacific already. And we've set up a Menti for our webinar today. If you scan that QR code, you should be able to hop on. You can either scan the QR code to answer those questions, or you can go to www.menti.com, and that's the code. And Sinead, if you don't mind putting that in the chat box as well, that would be wonderful. So it's still there when I close the slide. And the questions we've asked, which are a bit of a grab bag, a bit opportunistic, I have to admit, gathering some information about some of the topics that we've been discussing a lot, and be very keen to gather some opinions from you guys. So the first one there is, what term do you use for a water sealed toilet that discharges to a pit? And then what are your views on, for a given volume, what kind of toilet will fill the fastest? And that's a multiple choice. You'll see the answers on the Menti. And this one, have you used a well-functioning dry pit latrine in the Pacific that doesn't smell? So for those of us that have worked across other regions, we've certainly used well-functioning dry pit toilets. So just wondering if we see any of those, or any of you have used well-functioning ones in the Pacific. And then in your experience, what's the most common problem with septic tanks? So just getting gathering from our participants today, some more information. I can see we've got 36 people online, which is great. So just gathering your views on those as we go through. I'll stop sharing now and hand over to Sinead to share so that I can get that Menti up and running. We'll just leave that running over the course of the presentations. Hopefully you'll get a chance to fill it in between, and then we'll share the findings at the end of the Q&A session, assuming we have time. So I will end there and hand over, I should say, to Mark Ellery and ask Sinead to share. Thanks. You're right to unmute now, Mark. There you are. Wonderful.
Thanks, Bronwyn. Shall I share from my?
No, Sinead will be sharing. I think.
Okay.
Sorry, apologies. I'm trying to get it up. It's just loaded.
Thank you.
This gives the people. Did anyone have trouble getting into the Menti? This gives people a bit of time to have a look at the Menti while we're.
Bronwyn, it's Maria. We can't continue to the other questions on the Menti without you moving to the next question.
Yeah.
So we might need to have a session on it later. Up to you.
Yeah, it should be. Let me hop in there, and I think I'll be able to make it work.
Oh yeah, it's worked now.
So if you go, you should be able to progress through the questions now. Is that working okay?
I think so.
Yep, I think you should be able to get to them all now.
Okay.
Yep. Sorry, I had to operate it from my laptop here. Thanks, Mark.
Right. Thanks, Bronwyn. Can I click through the slides, or Sinead will click through? I'll call her through. Yep. Great. Perfect. Thank you all for your time today. And the Good Enough Guide to Sanitation is our ongoing attempt to reflect the complexity associated with sanitation and the need for trade-offs in optimizing sanitation in complex technological, social, environmental, climatic conditions that exist in the Pacific. Thanks, Sinead. And so what we're seeking to do in the Good Enough Guide is, rather than to focus on the what questions around the need for sanitation options and choices, to focus much more on the why and the underpinning principles that underwrite the various technology options. Thanks. And within this, breaking it down into, if you like, the common technology option, the common technology options, whether they're pit toilets, septic tank soakaways, and sewerage septic systems, and the on-site principles that will need to inform trade-offs for those. Thanks. And they're like really trying to complement the existing public health acts, the existing institutional infrastructure that underpins the choices, where it's really, local government acts and provincial council bylaws in rural settings, building codes and municipal council bylaws and building acts in urban, and environmental conditions for commercial establishments and public establishments. Thanks. And so while the acute consequences of poor sanitation are quite well known, and the exposure to bad sanitation increasing the risk of acute gut infections, diarrhea, vomiting, low weight for height in children, or high incidence of wasting, increasing the risk of child mortality that's borne as costs in the public health system. Thanks. What's less well known is the chronic implications of constant exposure to fecal waste, or constant fecal ingestion, that leads to colonization of the lower intestine with fecal bacteria, reducing the absorption of nutrients, inhibiting the growth of children, increasing the risk of stunting that leads to poor physical and mental development in children and in adults, and as a consequence places limits on the development of the failure of individuals and countries to reach their full potential. Thank you. When we look at the trajectory of male height over time, we see that the Dutch were not always the tallest people in the world, that the introduction of sewer systems to address outbreaks of cholera and typhoid also seem to have been associated with inflections in the changes in the height of men over time. And so the introduction of sewers and in Europe, and then later sanitary conditions in Japan and South Korea have been associated with long-term changes in the height of men, even though that they were initially intended to address acute consequences. They had knock-on benefits in addressing, obviously, some of the chronic consequences of fecal exposure. Thanks, Sinead. So in understanding, ultimately, we really want to understand at what point does the fecal waste that is being contained on site or transported and treated off-site, at what point is that fecal waste safely contained and being safely treated? Thank you. We know that aerobic processes are more efficient in the removal of pathogens, that neutralizing pathogens is performed much more efficiently by aerobic processes, and aerobic processes are much more effective in liquid that doesn't have solids and solids that doesn't have liquids, because it's much easier for aerobic organisms to penetrate liquid when there are not solids floating in that liquid, where the fecal bacteria can hide. Similarly, when sludge is wet, it's very difficult for the aerobic bacteria to penetrate wet sludge as compared to dry sludge. And so aerobic processes are much more efficient when liquid is clear and when sludge is dry. Thank you. And so while there are multiple technology options in the Pacific, and while there are sanitation behaviours associated with all of these 4 sanitation technology options, today I'm just really going to focus on some of what we're learning in regards to cesspit toilets, as well as septic tanks and soakaways. In understanding the, in septic tank and soakaway performance, I think probably the most important thing to understand is that septic tanks are not, the aerobic conditions that exist in septic tanks are not very efficient in the removal of pathogens or nutrients. Most of the pathogen or phosphorus removal occurs underneath the biofilm, in the aerobic zone underneath the biofilm. Thanks, Sinead. And while nitrogen will actually leach through and will penetrate through and underneath the soakaway, there is opportunities potentially for uptake of that from the plants or through exposure to carbon in anoxic conditions in the soil. Probably the important thing is that effluent that bypasses the soakaway will always have excessive pathogen and nutrient content, excessive levels of pathogens and nutrients. Methane that is discharged through the soakaway, some of that or most of that will be converted to CO2 within the soil. And so it reduces the overall carbon footprint. So there's an additional benefit of actually the soakaway in terms of its effect on global warming. And I think finally, probably the other characteristic worth noting from a septic tank is that it will concentrate the nitrogen within the tank. And so that when we remove the septic sludge, it will not only generally have fairly low solids content, but it will have a high nutrient levels. Thanks, Sinead. So what's happening, this, and a little bit, we're trying to look at the processes that are happening underneath the soakaway, recognizing the importance of the soakaway or a pit. It's really looking at how the interaction with the soil and the effectiveness of the soil in its removal of the various pathogens. Critical in the performance of the soakaway or a pit is this establishment of this biofilm, which is a black layer of gooey film bacteria that establishes underneath the pit. And that slows down the migration of the effluent through the soil and reduces the effluent absorption potential, but is extremely important in attenuating pathogens. And firstly, it's the parasites, which are the largest, which are the first to be attenuated. And they last the longest, but they move the least. Second is the fecal bacteria. So bacteria within the fecal matter are the second to be attenuated. And they're attenuated by the aerobic organisms that hunt below the biofilm. The third is the viruses, and the viruses are the smallest and the most likely to migrate, but they survive the least amount of time. And so in summary, we can say in roughly the first 1 meter of soil, all of your parasites, your bacteria, and your viruses will be attenuated within that first 1 meter. Now, their survival time is the risk they pose is dependent on both their survival time and their ability to migrate. And so in the Pacific, we see we have quite favorable conditions to reduce the survival time. So we have quite high ambient temperatures. In many conditions, we have drier soil, close to the surface, and not many microflora. And so those conditions are actually quite conducive to the reduction of pathogen survival times. So the survival times that you see listed there often will be shorter in the Pacific. The migration distances will also typically be a little less because we have saline environments often we have drier, unsaturated soils, and so therefore we can potentially manage. Often we have lower hydraulic loading rates because our systems separate grey water and black water. While phosphorus may get through and nitrogen will routinely be transferred through the soil, they are posing primarily an environmental risk rather than a health risk, and particularly in some of the densities that we're concerned with. And in dealing with our horizontal setback distances, we're really worried the migration time is dependent on the underground velocities of the groundwater. And typically, again, in the Pacific, we have very, very low lateral groundwater velocities. So if we're dealing with 15 days transfer time of pathogens, and our lateral velocities are in the order of tens or less than 10 millimeters per day, the travel time in the lateral travel setback distances will actually be much shorter than our guideline that are used as for advocacy for technology options. Thank you. Perfection aid. And so a couple of things where so when we kind of looking at the soil conditions, the actual differences between septic tanks with soakaways versus cesspits are not as great as what we would first imagine, because in essence, both of them are relying on the soil absorption system rather than the anaerobic or the tank. It's really the soil system that they both rely on, and when you look at it like this, are quite similar. There's a couple of critical differences. And with cesspits, one of the critical differences is that the cesspits fill up much slower than septic tanks because they run at much higher densities. And so we will actually see that, and we struggle to understand why cesspits are taking so long to fill up. And it is because they're naturally leaching systems. We've learned from dwellers in the informal settlements around Honiara and other places in the Pacific that when you're dealing with very dense soil, you can actually enhance your absorption capacity by placing rocks around your pits and enable these cesspits to actually accommodate very difficult and challenging soil conditions. And we do have with cesspits, we do have options that they can be emptied where trucks can't access, by switching pits and by alternating pits and by coming up with different ways of pairing pits together. And they're a much cheaper option than septic tanks. However, cesspits can't deal with fats and oils and grease. If you kind of imagine with a cesspit, where the grease comes in, it will seal the sides of the pit. The pit will no longer function if you have your fats or oil or grease from the kitchen or from the bathrooms coming into the cesspit. It just blocks the absorption capacity of your pit. Unlike a septic tank, which is designed to be able to deal with fats, oils, and grease. And the T pieces are designed to set so that you can still draw the gas in through and into the soakaway, and you can get the effluent in through and into the soakaway, but it keeps the fats out of the soakaway. Septic tanks offer some other options for segmenting and enabling the removal of nutrients, and they also enable you to do some other fancy things. And they can also be black water only. But the key difference, if you like, that sets the septic tank apart from the cesspit is that it can handle your fats, oils, and greases where cesspits can't. Now, this is an important consideration in the Pacific because Pacific plumbing typically separates black water and grey water, unlike many countries in the world. And so we're able to have this conversation, especially in urban areas, about the shifts and the comparative trade-offs, if you like, between cesspits and septic tanks. Thanks, Sinead. And so finally, I know when we empty cesspits or septic tanks, and transport it to a disposal site, the disposal sites are often quite technologically complicated, but actually we can simplify down the technology options as to whether we're designing our treatment system to leach nutrients into the environment, whether we're designing it, secondly, to concentrate nutrients, nitrogen in the sludge, and thirdly, if we're trying to concentrate nitrogen into the effluent. And those three kind of trade-offs basically define our different options for septic treatment that enable us to make the trade-offs in terms of the technologies that we want to apply for septic treatment. Thank you.
Thank you so much, Mark. That's a great overview of the different systems. Now we're very pleased to invite Sharon Lesser, who's a wastewater engineer with the Samoa Water Authority, to give us a commercial perspective on behaviour changes in off-site sanitation systems. Over to you, Sharon.
Thank you, Bronwyn. Hi, everyone. As Bronwyn has said, I'm the wastewater engineer for SWA. So my presentation is more like a case study because we only have one type of system here in Samoa that's under SWA supervision. So the behavioral changes will be more of an off-site sanitation because we don't treat the waste on site. Everything is being transported to our plant, which you'll see in the next few slides. So the commercial perspective as shown on the title, it's basically because we only connect the commercial customers at the moment. So just a quick overview of what we'll go through. I'll quickly give you a background of who we are and what we do. Then there's our typical sewage connections, the regulations that we use to control what can be discharged to our network. And then there's the common issues and also the corrective actions that we take when it comes to our pressure sewer pump stations. So we'll also show you a little bit about the works that we're doing at the moment in order to optimize our system and make the most use out of it. Thanks, Sinead. Okay, so SWA is the main water utility in Samoa. At the moment, we're only servicing around 85% of the population. The other 15% is under the independent water schemes. So this is where the villages, they take care of their own water sources. At the moment, we're nearing around 30,000 metered water connections, and we only have one wastewater treatment plant that's located at Songi in the Apia CBD. So the treatment plant and the pressure sewer network was commissioned in 2010, so it's relatively new. And we have around 124 sewer connections at the moment. We have 112 pump stations and 7.6 kilometers of sewage mains. So the treatment plant at the moment, it's only operating at 60% of its average dry weather flow capacity. So it's not yet at full capacity. Thanks, Nick. So the diagram that you're seeing, that's the typical drawing that we give to our new customers and also some of our existing customers. And it just highlights which section of the sewer system that they're responsible for and which one that's under SWA. So as you can see in the drawing, SWA is only responsible for the pump station, which starts from the tank up until the sewer main. And the customer is responsible for their own internal plumbing and up until the point where we connect it to the tank. So there are some special cases where we can help out with connecting the customer's internal plumbing to our tank, but this is usually a subject to approval from our managing director. Thanks, Shanique. So some of the regulations that we have in place in order to control what can be discharged into our system, as you can see there, we have the sewage and wastewater regulation. And that's the one that basically states that SWA is only mandated to connect to commercial customers in the Apia CBD. And it also states that if you're a commercial property and there is a sewer line that's in front of your property that's available, then you need to connect to the SWA network. So we tend to use our SWA trade waste policy to control what can be discharged into our pump stations. And it also states whether our customer will need to have some sort of pre-treatment like a grease trap before they can use our pump station. So for our wastewater treatment plants, at the moment, the effluent that's being treated has to comply with the SPREP regulatory standards, but we're also preparing for the rollout of our own national effluent discharge standards. But there's gonna be some work there because we need to make sure that the treated effluents will be able to meet the new limits for the effluent stated in the national guideline. So for our customers, we always make sure that they are aware of their responsibilities as stated in the regulation and also in the trade waste policy before they can sign on the pressure sewer installation agreement and also the customer agreement. So from our point of view and some of the behavioral changes from our commercial customers, around 60% of our call-outs on a monthly basis, it's usually because of an overflown sewer tank that's caused by a pump blockage. And this is usually because someone flushed away something that they shouldn't, like a rag. As you can see in that photo, we've also found some plastic bottles in some of our tanks, but that's usually the case. And from our point of view, this is because of the lack of awareness when it comes to the public. Because our system is relatively new compared to water, not many people are aware of what they should and should not flush down the bathroom. So this is something that we're working on at the moment to kind of increase people's awareness. We also put up quite a lot of posters around the public toilets in town so that people are more aware of what they shouldn't dispose of down the drain. Okay. So from our point of view as well, and this is one of the biggest issues that we have, especially with our commercial customers who have restaurants, they tend to violate a lot of the SWA trade waste policy. And in some instances, we do issue the warning letters. We need to tell the customer they need to clean up their pre-treatment or their grease trap. And there was only one severe case where there was someone who was pumping seawater, but that was a case from last year. So we had to issue the whole cost recovery and also upgrade the pump station. But the problem here is because at SWA, we're not very strict on enforcing the rules that are stated in the trade-based policy. So we tend to bear the consequences sometimes because we have to clean up the pump station if the customer doesn't do their part. So the other biggest issue that we also found from operating our system, that there's a lot of indirect and also sometimes direct stormwater discharge, which was clearly stated in the regulation that it should not be connected to the pump station, but this can be an issue. But we are working on it at the moment to reduce or identify the points of high inflow and infiltration. Yeah, that's the next slide, please. Okay, so some of the works that we're doing at the moment is to maintain our assets and also keep it functioning for the next few years. As you can see in those photos, we do annual maintenance on our pump stations. This is to make sure that they can last longer and be until the end of their lifespan. So some of the other things that we're rolling out as well is our SCADA and telemetry units. And this is basically for us to be more proactive to our customer response time. And it also helps us do some remote monitoring and some controls. So at the moment, we do have an increasing number of pump stations being installed. So we also get a wider complexity of issues. So we do have to upskill our staff on an annual basis or when there is a need. So we have to keep on training them so that they can deal with the new issues that come with operating a pressure sewer system. Okay, yeah, that's it for that slide. So this is also one of the biggest things that we're working on at the moment, because our system in Apia, it's a completely pressurized system. We don't have any sewer gravity mains. So operating 112 pump stations, it can get very expensive because of the electricity bill. So SWA and their current works at the moment has to do with optimization. And this has a lot to do with flow controls and also smart control panels. And basically what we try to do is to identify the times when the pumps can be operated so that they are not all pumping against each other. Because if all the pump stations are operating at one time, not only does their efficiency go down, but the electricity bill just goes through the roof. So that's just some of the ongoing works that we have. And the main goal behind that is that we need to optimize the system that we have before we can kind of increase the network and also increase the number of pump stations. If we do want to connect the domestic households in the future, then we need to make sure that we have complete control of the one that we're running at the moment. Yep. So that's the behavioral changes and also from our end. Thank you.
Yeah, thank you so much, Sharon. That was a great overview of the system that's now installed in Apia and how it works and some of the challenges you're facing. And so really interesting presentation. Thank you so much. We will take all the questions at the end. I see a couple of discussions popping up in the chat, and do feel free to write any questions for Sharon in the chat for the Q&A session as well. But now I'll hand to Raghava Neti, who's a Senior Water and Sanitation Specialist at the World Bank. I had the pleasure of meeting in person recently, which was great, in Fiji, and he's now based in Fiji. So over to you, Raghava.
Okay, thank you, Donian. Thank you. Thanks to ADB for inviting me for this presentation. Essentially, my topic is about what we are planning to do in Kiribati through the South Tarawa Sanitation Project, which has been approved recently in May 2022. Before we move on, let me say that we are yet to implement this project. It is at the initial stages. The client is Ministry of Infrastructure and Sustainable Energy. They are supposed to get the capacity built and get the PMU to get on, which is yet to happen. So next, please. Okay, today my topic covers 4 areas. One is why we need on-site behavior change, and what are the hurdles in getting to that, and how to tackle that. And how we are addressing these issues in our project by bringing World Bank's global knowledge, as well as based on the experiences in Kiribati, how we are building on that. There was a project financed by ADB earlier. We are trying to build on that. The key takeaways from this presentation are, as you see here, in terms of on-site behavior change, as you have seen in the earlier presentations, it promotes ownership. We can promote use of the toilet that are built and the systems that are built, and it promotes sustainability ultimately. In terms of hurdles, they vary based on the context of the country, the situation, the capacity of the institutions, the culture of the institutions, as well as the people in the country. How to tackle it? It has to be planned strategically right from the beginning, and interventions have to happen much earlier to be able to address the challenges. Both the governments as well as the utilities have to get involved, and they have to mobilize the community as well to address the challenges. In terms of our knowledge, the takeaway is that we have many publications in this area, which I'll present, and we have tried to use the knowledge generated through those knowledge products. And we need to ensure that there is proper governance in the country. And then implementation has to start, because we cannot be waiting till the end. It has to start right from beginning, involving all the partners, including we have to take on the experiences of the other development partners as well. We are trying to do that in Kiribati. Over to you. Next. So let's look at the topic why. In terms of why, toilets that are built have to be connected to the network. Toilets that are built have to be used. And once everything is in place, we need to ensure that the system will function properly. You have seen in Samoa presentation that the sewer network is not being used properly. So we must ensure functionality, and then ultimately the community has to pay for services, at least part of it, and the remaining part may have to come from the government. Next. So the takeaway here is promote ownership, use, and sustainability of the systems. That is why on-site behavior change is very much important. It goes beyond the behavior change and communication, which we normally plan in the projects. It has to cover many topics, as you see here. Next, please. So what are the hurdles in that? The hurdles are mainly in terms of connections. The hurdle could be that connection fees is high. Therefore, the community may not be in a position to pay that. Some of the areas in the network would have got left out, and therefore people won't be able to connect. There are no toilets for some of the people, and there is no money to do internal pumping. It may be so happening that the utility might be constructing the sewer network, and then it may be asking the community to do the internal plumbing, for which they may not be having money. And finally, it is also with utilities delivery capacity. All these lead to connection issues. In terms of usage, there could be prevalence of ODF, and it requires huge change in terms of community behavior to be able to bring them onto the stage to use the toilet. There could be non-functional or poorly built toilet with blockages, no maintenance, poor ventilation, concern with the type of technology, etc. All these lead to toilets not being used. There could be access difficulty, which means suppose communal toilets are built at some place, but some of the households may not be in a position to go there and use it. All these lead to usage difficulties. And in terms of functionality, there could be problems of maintenance. People throw trash into the toilets or manholes, which obstructs the sewer system. There is no water for flushing the toilets or washing the hands near the toilets. Or the toilet would have been built near the water sources, polluting the water sources, etc. All these lead to functionality issues. In terms of cost recovery, issues with affordability, willingness to pay, and willingness to charge, these are all the issues. So we need to keep all these points in mind to be able to address the hurdles. Next, please. So how to tackle this thing? So let's look at the scenario when we plan a project like this from the World Bank side or even the ADB. The attempt is to analyze and understand the context and issues in the country properly. What were the interventions which have happened earlier? And then what kind of experiences have been there in terms of moving ahead with the implementation, whether there could be contract related issues, there could be land related issues, etc. Or even, of course, the community's social behavior, all these issues have to be understood properly. And also, we need to learn from the experiences. For example, in Kiribati, what we understand is that the network was built, but the connections have not happened. So we are trying to address that in the World Bank project now. In terms of on-site systems, around 34 on-site systems were planned earlier. Only 6 have progressed because the contractors didn't have capacity. Therefore, we are trying to see how best to facilitate this. Next one is about facilitating behavior change. So we need to look at the kind of interventions which are appropriate to the social context so that people will be able to understand the issues, they will be able to adapt the new behaviors. So it requires understanding the local context again. Next thing is about building skills to address all these issues. We need to understand which are the implementing agencies, which are the utilities that are getting involved, and then what are their skills in terms of handling these issues, and then some interventions have to happen in addressing the capacity gaps. Next is about communication. It has to be two-way. That means, please remain in that slide, please. It has to be two-way, which means that the messages have to go to the community, and then the feedback has to come from the community as well, so that interventions can be tailored as the implementation progresses. Finally, in terms of monitoring and evaluation, we can only manage something which is measured. Therefore, every intervention has to have some robust monitoring and evaluation system. These are the ways in which we can address these issues. Next, please. So, the World Bank has developed some of the knowledge product, as you see here in this slide. We have something called Connecting the Unconnected, which essentially capture the issues of various hurdles that I've explained earlier, and then they have prepared some strategies. We are trying to adapt this in Kiribati. Then there are issues of city-wide inclusive sanitation, which means that always it is not necessary that we need to have sewerage system. There could be a mix of technologies which can be more suited to the local context. So a global knowledge platform is available, wherein even ADB and the World Bank, along with others like BMG, have got together and developed this kind of knowledge on city-wide inclusive sanitation. We are trying to adapt that in the project. Then with respect to shared and public toilets, there should be models which will work to maintain the system to ensure that people use them. So there is again a knowledge project developed. We are trying to use that in the Kiribati situation. Next, please. So in the project, I'll go a little bit deeper as to what kind of interventions have happened. Next, please. You see here the map of Kiribati. These are the project areas that are being shown here. Essentially, the interventions are in 3 towns, Bishio, Bairiki, and Bikanyabu, the red ones that you see here. And there are villages in green shaded. There are 4 villages wherein the on-site systems are being provided. In these 3 towns, there was a sewerage system existing earlier, which was implemented under the ADB project. The World Bank project is not trying to expand the sewerage system in these areas, but only try to connect the households existing in these areas to the existing sewerage system. If there are any further rehabilitation requirements there in these sewerage systems, the World Bank project will try to address that. Next, please. Yeah, next slide. So the project has the 4 components, as you see here. The first one is focusing on infrastructure to improve the sanitation access and also address the issues of liquid waste management, fecal sludge management that you have seen in Mark's presentation that is being addressed in the project. Next one is about operational maintenance, institutional strengthening, and sector improvement that focused on PUB, which is the public utility there. This component also has focused on MISE, Ministry of Infrastructure and Sustainable Energy, to build their capacity. It also looks at some of the regulations aspects which were presented earlier in the previous presentation. Next is about community engagement. We also have a water project in Kiribati. This project, sanitation project, is trying to build on what is being done under the water project. So we have been also discussing with other partners like UNICEF to see what is happening in the country, and then this World Bank project builds on that. Fourth one is about project management. The total funding at the moment is about $20 million to cover all these components. Next, please. So this slide is important because it presents all the interventions that the project has. Senior, just go slowly one by one. I'll read out all the points which are coming. So first one is about network. Connect the households in the seaward areas. Don't expand the network. Because we thought that if we expand the network, then the problem is going to be huge because we may not be in a position to address all the challenges. So the focus is limited to connect the existing households where the sewer network is existing. Try to understand what the community is doing, what are the challenges in connecting, and then scale up if necessary, maybe in the next intervention. Next, Senior. Second one is, we understand that both in the seaward network area as well as non-network area, people will not have toilets, some of them at least. So the project tries to provide toilets to those which are lacking, either through individual or community toilets. The other issue we debated very closely is what to do with the financing, because one of the issues in Kiribati was that they may not be in a position to finance the cost of the toilets. Therefore, the project had interventions to finance everybody 100% of the toilet. But then we need to have some kind of assessment as to who is eligible, how much, etc. That will be addressed in the project. So ultimately, the objective is that all the project areas will have toilets. Next one is involving the local government. Specifically, there are 2 local governments covering these urban areas as well as villages. We spoke to them. We tried to involve them also in terms of planning and implementation. The other thing is adopt traditional approaches for community discussions. We understand that they sit together, the communities sit together in the hut-like formations, and then they discuss the issues. We try to build on such kind of approaches. In the non-network area, in the villages that you saw earlier, there will be a community sanitation agreement which will be signed involving the local government and the community. A decision made in the local government resolution that they want to go ahead with the project. They agree to the requirement. So by that, we hope to have some ownership by the community. Next. So water project has wash awareness raising. The sanitation project will build on that. But our main challenge is to design the open defecation free approaches. How do we get to that in the project? Because the project has an indicator that at least all these 4 villages and the urban area should be open defecation free by the end of the project. So this is a challenge. We probably also draw upon experiences in the Pacific. If you know anything, please share with us. We'll try to build on that. Next, please. Then strengthening the institutions, MISE, PUB, in terms of staff, equipment, and coordination, all that will be addressed in the project. Reviewing the regulation and strengthening them along with MD systems will be part of the project. Next. One of the challenges which we have noticed is that there is a need to have good databases. At the moment, they don't exist. So we bank on MISE to maintain such databases, MD systems, and also they have to measure the result ultimately to see where we are going. Next. The knowledge project that I have presented earlier, they'll be used. Also, we build on the work of other partners, including ADB's approaches earlier. Thankfully, ADB team had some lessons learned from the earlier project. We try to bank on that. And then we see that now the risks are minimized through those integration of lessons. Next. In the non-network areas, in the villages that we see, the attempt is to use appropriate technologies. At the moment, 3 technologies, 2 have been identified. One is septic tank with HDPE container, and the other one is pit-latrines. The population profile has been divided into different percentages. We assume that at least 50% of the population will depend on communal toilet, 25% on power flush toilet with HDPE tank, and 25% remaining depend on upgraded communal toilet. There is a model existing in Kiribati. We try to use that. So that is how the whole population is divided. There will be also sillage reuse that is attempted in the villages. Next. In terms of cost recovery, the project has affordability studies, willingness to pay studies, tariff reviews, etc., to come up with appropriate levels of tariffs. We were discussing with ADB team under the ADB's South Tarawa Renewable Energy Project. There is a comprehensive tariff analysis, including all these studies are planned. So we look forward to that assessment completion, so that both for the water, sanitation, as well as energy, there will be appropriate levels of tariffs. We understand that there needs to be continued cross subsidy between power as well as water sectors. So that may continue. We'll have to see how it comes up. Next. In terms of operation and maintenance, which is very important for the network, we are trying to see that there could be an operator. For the water project, at least there is an operator contract which is going to come soon. We are trying to see how to coordinate with that contract. At least for sewer network, there will be, again, another operator or say scope of work increment for the water project. In the non-network areas, at least for the communal toilet, there will be owned them through community groups, which we are trying to see, which would also improve, hopefully, the jobs and strengthen the local economy. Next. I think this is the end of it. So thank you very much for listening. Probably I look forward to your questions.
Thank you so much, Raghav, for that overview. And I found it particularly interesting, the final slide about the details of the project and the different elements, which kind of cover all the way from interventions, infrastructure, through to community engagement, through to system strengthening as well. We will have our Q&A session now. So can I please ask our presenters, Raghav, Mark and Sharon, to turn your cameras on and unmute. We might just go to that. Okay, great. So we did have a few questions come through during the course of the presentation. I think we might start with our technical one, Mark, which is to you, which is the question is there anything one can do to encourage the growth of a biofilm in an open bottom perforated cesspit?
Great question. And it's really,
Nauru.
Thanks, Freddie. There has been laboratory research, and one of Bronwyn's colleagues from International Water Centre, Cara Bill, did research on the establishment of the biofilm and how long it takes, and the influence of that, even in very gravelly soil, to actually its effect on the absorption capacity of the soil. But in terms of actually what you do to promote biofilms within cesspits, it's again, I think, one of the areas where we don't know, and there's research. It's one of the, we have these set of questions where we don't know the answers to. And so that's one that we're really, and we don't know whether the biofilm necessarily, which way it grows. Does it grow laterally and then scoop up at the sides, or does it follow quite closely at the sides? And so there's a whole lot of questions around the biofilm that we're hoping to engage academic institutions to help us answer some of those questions. But great question.
Thanks, Mark, and I hope that answered your question, Freddie. The other question, we had some comments come in from Terry Lancashire. Did you want to say those rather than me reading them, Terry?
Thank you very much for that opportunity. I wasn't expecting that. I have experience in South Tarawa that preceded Ravi's project. There's a sanitation roadmap addendum delivered under New Zealand MFAT, which looked at the options around the sorts of sanitation treatments to be applied in South Tarawa. My comment, and they use a saltwater flush system, which is proven to be inefficient for maintenance. It's been rebuilt 3 times. And I think my comment is that the locations, I think, need to be looked at individually and not in a regional way. What I've seen today is an excellent presentation from Samoa. My understanding of Samoa, and I apologize, I haven't been there, is that it's a volcanic island, and looking at that excellent sanitation treatment plant, wastewater treatment plant, they have a larger landmass to be able to do that. In South Tarawa, there is significant pressures on land use, and it's a low, small landmass atoll island. And so I think with respect to all the experts, because I'm not one, we need to look at the locations individually, because the use of cesspits in South Tarawa has resulted in the freshwater lens in Besio being contaminated and not become not suitable for use. The other segment of the other villages are similar. There's only one remaining freshwater lens, which is the Bonriki Water Reserve. And so that's sort of my comment, and like all of the presentations have been excellent. The comment I made about the excellent presentation from Mark Ellery, was that those vertical and horizontal separation distances to what had been the primary in the past water sources in South Tarawa are just not achievable, and that's why it's been sort of the water lens has been compromised. I compliment
comments, Terry.
Okay.
I think that's plenty for us to go on. I think, yes, definitely the sanitation solution needs to be contextually relevant, and so the context in Samoa is vastly different from the atoll context of Kiribati. Mark or Raghava, would you like to respond?
Yeah, quickly. You're right, Terry. I think land issue is very big in Kiribati. So I agree with you that every location has to be seen. So there is a challenge in implementation, though the concepts are there. There is a robust assessment needed as to which kind of technology is suitable to which place. So that has to happen now, once the ministry mobilizes their team. That's one. Secondly, in terms of saltwater system, I agree with you. There were challenges of maintaining the saltwater system. But the World Bank's project is trying to connect the existing rehabilitated saltwater systems to the households so that people will at least use the saltwater. Earlier, we understand that because the system is not connected to the toilets, nobody is willing to go there and take water from the saltwater system, come back to the toilet and use it. So hopefully, I think it will work. We'll have to still see. But the maintenance is a bigger thing. It costs a lot. So we need to see how best to manage both these requirements. One, limited water availability. Second, how best to use the salt water for flushing.
Thanks, Raghava. Did you have any further comment, Mark?
Just only to say that absolutely the technology has to be tailored for site conditions, but some interesting work in Bangladesh that showed that 99% of the risk to water sources is over the top risk and 1% was through the ground. And so when we say the groundwater is being contaminated, we need to distinguish between the groundwater versus the groundwater source. Often the source is contaminated over the top and we say the groundwater is contaminated. No, the source is contaminated. Now it's really difficult, but we need to distinguish, is it the groundwater source that's contaminated or is it the groundwater? Because the groundwater gets a bad rap, but often it's not coming through the groundwater, it's coming over the top. And in Bangladesh, with pits sitting in the water, they showed that, they basically had to protect the sampling devices, because often one of the risks is when you put in a sampling, you contaminate the actual samples that you take. So they had to put in sealed pumps and contamination to protect from contaminating the detection devices. But all points are very well taken, in regards to the citing of technologies appropriate and that need for mix of options. Thanks.
Thanks very much. There's also a question here from Vasiti asking about what the consideration or what needs to be considered with rising sea levels and king tides from the I guess sanitation system point of view. Raghava, do you want to speak to that?
Yeah, thank you. I think this is an important issue is in Kiribati. So essentially, we need to see that the flooding, the zones of flooding where it might happen, and see that the toilet locations are properly elevated. So we're trying to strengthen such kind of climate resilient measures in the toilet design. There was some concepts already built into the project. So we'll have to see how much they can be implemented. Essentially, it requires, again, based on my answer to the earlier question, location-wise detail as to what we can do.
Thanks, Raghava. Any further comment, Mark, or we might go to the Menti? I'm quite keen for that, to see some of the results.
I'll just say that flooding is a real complex, because even with pumped sewage systems, flooding actually, gravity systems, it will overload those, and so sewers aren't the logical, easy option for flooding, even though pressurized sewers try to manage that risk. But I will say for on-site wet systems, one of our interesting questions is when a cesspit or a septic tank gets flooded, but the toilet's still above water, your hydraulic gradient is still downwards. So it's not posing a risk to surface. And so, that would be, so I think we're interested in asking the question for on-site water seal systems, do king tides and inundation actually pose a faecal exposure risk, or are they a downward gradient risk that needs to be managed that way rather than at surface?
Thank you both. I do want to take us to the Menti. We have more and more people getting on there. So I'm going to share my screen, which is the results. So I think the last time we did it and I wasn't sharing, it didn't quite work. Not everyone could see all the questions. So we'll go through them, and there's some interesting results here, some really interesting ones. So what is the term you use for a water sealed toilet that discharges to a pit? And I particularly like the toileti palangi. Wondering if you put your hand up if you put that one in, or if they're still here. You might have left. We did lose a few people earlier. But there's some interesting ones. Pour flush, septic tank, pit latrine, pit toilet comes up a few times. Pour flush the most. Okay, so if I move to the next question, you should be able to follow me. So for a given volume, which of these toilets will likely fill the fastest? And I think Mark did give a bit of the answer away in his presentation. So we'll see if how we got. And also it's probably based on your experience as well as sanitation professionals. Can everyone see that question when you're going through?
Yeah, we can see it.
Thanks, Kate. So I think you have to click through when you're actually in there as well, because we had 17 people on the previous slide and then 10 so far on this one. Any comments on the results, Mark?
Yeah, a septic without a soakaway will fill the fastest, and then yeah, cesspits are often smaller, so they create an impression, and sometimes the cesspit fills quickly because it doesn't have the soakage area around it. But in those conditions where you can make sure that it's got enough a big enough surface area, it is definitely, you know, like it will be a septic without a soakaway.
Yeah. See some answers still coming in. Thank you. I might just skip over the next one. That's kind of the same question framed differently. And just because of time. And then this one, we've had one answer so far. Have you used a well-functioning dry pit toilet in the Pacific? Really interesting. That's good. I guess we're quite interested, I mean, in the terms of the systems we're talking about today, we are looking at the whole range from Seward through to completely on-site household management. So it'll be interesting to know, and we'll hopefully in our training that we're doing next year have a chance to explore and find out which countries, because obviously, as we've seen today, the situation is so vastly different across different Pacific Island countries, where the technologies are, which technologies are working well where, I guess, is also what we're interested in kind of exploring more. Looks about even. Yes, there's a nose there. Oh, the compost toilet. Thanks for CT. So the CT's added a comment that the compost toilet doesn't work. Oh, and Shinjini's been to a beautiful bush toilet. Wonderful. That's great. Was that in Vanuatu, Shinjini?
No, it was in Australia.
I guess we count as in the Pacific, don't we? Okay. And then our last question. What's our last one? Oh, I've gone too far. Oops, sorry. Yeah. So in your experience, what is the most common problem with septic tanks? So we have 10 answers in there so far, so we're still waiting on a few to hop in. So we can see no soakaway attached to the septic tank, so it fills regularly, is getting a lot of votes there, which certainly we see in some countries is a regular problem. Okay, more regular than other problems by sound of it. What's the comment here from Rosie? For odor consideration of the brown carbon heavy materials that added can make a difference. Yes. So helping the aerobic digestion process by adding carbon. Good point. And what's this? The CT, too expensive to buy and install. Do you mean the septic tank's too expensive to buy and install for CT? You can unmute. Or maybe clarify in the chat. That's quite interesting, isn't it, Mark? The results that the most common problem people are identifying is the fact that there's no soakaway.
Yeah, and it really is, like, because I think in some ways, like there's, as we've had this thought that let's contain it in a concrete block and, like, and keep it safe. But then I suppose when we pump it out and take it away, or when it overflows, it's loaded with pathogens. We've done nothing really to reduce the pathogens. But I understand, that idea that we contain it to keep it safe. We don't let it go into the soil. But the soil in this is really our friend.
Great. Well, thanks for participating in the Menti survey. I think we're pretty much wrapping up. It's been really interesting. Thank you all for your contributions. And I see there's still, one more question for you, Mark, from Rob in PNG. Do we have data, any studies from the Pacific Island countries with respect to stunting and poor sanitation? How widespread is it? Good question. Actually,
very good question, Rob. Bronwyn and I were having this discussion just before, we've got, there is some really good data on open defecation, correlation between open defecation and stunting globally from the DHS surveys. And what's fascinating is that the correlation is not between stunting and toilets. There's no correlation between stunting and open defecation, but an extremely strong correlation between stunting and the density of open defecation, or the density of shit, if you like, in the environment. But for Pacific Island countries, because it's so complicated, it's complicated by the surface area. So the open defecation density per capita is really complicated because of the sea, the influence of the water surrounding, and so it probably, we haven't been able to generate that open defecation density data, but we thought we might have a go at it, and hopefully we will try and answer that question and create a database of open defecation density against stunting for the Pacific Island countries. So watch this space and we'll try and generate that graph. Yeah, I think it's a good question, Robin. I haven't seen any big studies on that coming out of the Pacific as yet, but certainly it's we see it elsewhere in the world, as Mark said. Now's a chance for us to please take a photo. So if you don't mind, if you could turn your camera on, see your beautiful smiling faces, and we'll take a photo screenshot. All right, I think we've got a few people taking screenshots. If you don't mind, turn your camera on, give us a big smile. Thanks so much for participating and listening to a session on toilets in the Pacific. We'll try and get the 2 screens. We've got quite a few participants, so it's spread across a couple of screens for me at least. Can you let me know when you've got them, Sinead, as well, so that we're juggling it a bit, aren't we? All right. How are you going, Sinead? Done?
I've got mine. Yeah.
Great. Okay, well, thank you so much. Especially thank you to our presenters, Mark, Sharon and Raghava. Really fascinating discussion. And I think really important that we keep this conversation about sanitation going from household on-site to septics through to sewered, and what suits in what places across the very varied context in the Pacific. So very happy to keep this going. If you are coming to the conference in Brisbane, really encourage you to come along to the training. It's on the Friday. And in the meantime, enjoy your work in sanitation. Bye, everybody.